If you are using Kubernetes, you have probably run into the situation when your team deploys something in your cluster and a container with high resource limits or a Docker Hub image with the wrong username or our account just pulled from your Docker Hub account and to your cluster. And there's something like happened. You got to know when something happens in your cluster, maybe some messy things. So these are the problem that we are facing. So how do we actually solve it? So that's what Kyverno comes in. Kyverno solves your all this lighting policy management thing, and you got a clear understanding by the end of this video how to use it and why we are using it in our ecosystem. So let's get started. So before talking about the Kyverno, I want to make sure that we are on the same page. And what are the problem Kyverno solves here? So Kubernetes is very flexible, right? You can deploy like anything. You just have to define a YAML and it will deploy in your cluster. So, but that flexibility becomes a problem when your multiple teams are working on the same cluster and applying the same and different things. So you got a developer team who just ship features, and platform team like stable, like try to make a stable cluster always, and we got a security team who just caring about the compliance and requirements. So everything is like a defined YAML file, right? And Kubernetes just take it and applying in your system without checking it. And it doesn't care like if you're using a memory limit or you're running as a container as a root or you are just forgot to add a level in your multi-system, right? So that's the problem. It will just say just state it and let's move on. Communities are also comes with some resource data and limit range, but that are some basic things that you can do in your cluster. You can like do a complex policy enforcement in your cluster, and that's what we actually need. That sits behind your T and your cluster, which like automatically reviews and enforce the policies in your cluster, and that's what Kyverno does. So Kyverno is a policy engine for Kubernetes. You define root call policies in YAML, and it automatically reviews and applies in your cluster. And it's a CNCF graduated project, which basically means large build or large number of developers are already using it in their production scale. Best thing is you don't have to remember complex system. If you know YAML, then you can write your own policies and you can enforce in your cluster, right? And there's a huge policy library maintained by the community, and the developers are maintaining it. So like if you want to use policy, then you can check there and you can customize it and you can use on your cluster. Now let's see how Kyverno works inside the cluster. So Kyverno runs as a dynamic admission controller inside the cluster. So this is how the flow will looks. Suppose the developers will submit some resource requirement. That resource requirement will go first to the API request, the Kubernetes API server. Then it will just go to the authentication authorization. There is some authentication authorization will happen, like it will check is the correct secret or not. The following user have a correct RBAC permission or not. Then there is a next phase in mutating admission. So mutating admission will check is that any mutating it will cover does it cover in any mutating policies or not. So if we give an example, so this is how mutation policy looks. So it's like it is the user requirement file, then the pod. So it will just match the constant if the it's made something and which is in the mutation policy. So in the mutation policy, will say if there is something in mind, then add something mutual policy in the YAML file. So it will just take the old YAML file and update with the new one. So it can be add or something, or it can be remove the old constraint, and it can be just add and just change it to the new one, right? This is how it works. And then just hand over to the next phase. It will not just save first to the etcd. It will just check all the things and then it will just send it the next phase. Okay. Then there is the next phase, the schema validation. Schema validation will check that following the resources is correct for the schema, right? Just check the following resources like correct or not. Like all the validation, schema validation will happen. Then there is the admission controller. Validation admission controller. So validation admission controller have like this much of things. It is very like where the compliance and security compliance policies are enforced. So it's does various things like it will just whenever you are applying some new policies on your cluster, so it will check that it is accepting the permission or not, right? So there's like some policies, resource limits required, approval container registry, no privileged container, like or labels if there's following levels or not. So like this type of policies you can create. There's like validating policy, mutating policy, generating policy, deleting policy. Validation will perform like is that the following resources will accept the memory, CPU construct or not, image tag like that. Okay, and then we have here a cleanup controller. We have built just delete the old policies. So like you define something, and if it's need to be deleted, there is some deleting policy here that you can create. It will just delete the thing which you have declared in your policy. And the report controller will do for audit stuff, or like if you define something need to be reported in the whenever you apply, so it will just report on to the user. And there's a background controller. So background controller will take care of your which you have already declared in your cluster resources, right? So background likes how like existing pods will get evaluated, existing resources. So it will just check and check the policy and will just do the changes on your cluster. And there's a Webhook controller. Webhook controller is responsible for communication between your API server and the Kyverno, which sits, which will on your cluster. The Cert Renewer will be responsible for your cert management, rotation, and everything. Okay. So now let's see demo how Kyverno will work. So first you need to install a help package to run into your Kubernetes cluster. So let me get the help package and let it install. And then you'll see some example. We'll create some policies and then apply to the cluster. So if you go to the documentation, I'm going to apply all container needs a resource requirements and limits. So let's just copy this and then apply create policy. Okay, so what the policies will say here? So here we are creating as a mesh resources a kind of pod, and validation is actually is enforced. That method will show all the container master, CPU, and memory resource and limit defines. So like whenever the pod will create, it will check that it have a resource defined or not. We are as a resource we will define in the memory and CPU. If it has something, then it will create. If it doesn't have, then it will just give this messages. All container master, CPU, and memory resources are equal, defined, right? So now let's apply this policy. Create policy YAML. So now let's try to create the pod without any resource constraints. Okay, so YAML. Let's say it. Okay, create -f. So here it's saying that Webhook Admission validated Kyverno denied the request that because there is a validation error. All container have CPU memory limit, right? That's why the YAML is not applied. So if you want to let it apply, then we need to add a resource constraints or our pod.yaml. So let me add the resource limits here. Now if we try to create it again, so now it will allow us. Okay, so now it's allowed us to create it. We check. So it's showing pending. After some time it will list up. So this is the example of some validate rules. Now we'll look at the mutate rules. So I have an example. Let me share some. So what actually mutate will say is if you are going to apply some YAML, if there is a mutation policy will define, so it will do the changes. So I have some policies that we can try out. Okay, so it's saying something that is not required. Maybe it's something different error. But let's jump into the other section. Let's create another policy. Add environment label. Add level car resource kind is This was this was a kind pod, and namespace will be defined as a prod. There's like for mutation, patch, staging, merge, label, data labels in production. So whenever we try to create a pod in the production, in the prod namespace, it will automatically inject that particular label. Okay, now let's try this. So let me create another pod in the prod namespace. So first I need to create a namespace prod. Then we need to apply some YAML. Okay, so look at the mod to YAML. It is creating in prod namespace, I think. Okay, so let me just apply this command. Okay, like enough prod 2, and I want to create in the prod namespace. So when we create it, then let me try to get pod the show labels flags. So it's saying environment labels as environment production. So I haven't declared any label in the YAML, but it applied after I just created a pod, right? So let's see what the mutation policy will do the job. So there are like sample policies that you can try, and you can try and check which one suits for your workflow. So in the end, I would say Kyverno is a policy engine for Kubernetes. You can validate and mutate resources easily, and you can also integrate the stuff as well, like a CI/CD or Argo CD, like that. So these are the things, and CNC is it's a graduated project, CNC graduated project, so you can use that. And yeah, if you already find this video very helpful, then give some support. You can share with your team, and just like it and subscribe it. And I will see you in another video with another topic. Till then, keep learning. Goodbye.